So, welcome back. And in this video, we are going to learn something called resolving forces. Now, if you remember, in the last video, all the forces that we were dealing with were either acting horizontally or vertically. And even the example questions that we did, we had forces acting either horizontally or vertically. So I was pushing the car and my finger was horizontal, or in other words, parallel to the table. And at the same time, if I'm pulling it, the force that I'm applying is still parallel to the table or horizontal. And just like that, when it's stationary, there are two forces, and those two forces are also acting vertically. One is downwards and the other is upwards, or you can say perpendicular to the table. Again, we'll study more about these forces later on in a separate chapter. But what's important to note is that the forces were acting horizontally and vertically. Now, that's not always going to be the case. Sometimes what will happen is you'll have a force which will be acting at an angle. Now, here's a Batmobile, here's a string which I've tied. Now, notice what happens as I apply some force on the string to pull it. It's moving forwards, right? Now, what's interesting to note over here is that it's not moving in the direction of the string, rather it's moving forward. And in fact, if I pull it really hard, it even lifts for a second. Now, why is that? That is because you see the string, but what you don't see are the x and y components formed by the force that I'm applying. Now, notice the shape that's being formed over here. Imagine that you have a horizontal line here from where the string starts, and it goes all the way till when the string ends. And from that endpoint, you have a vertical line, again, going all the way where the string ends. So the triangle that's formed over here is a 90-degree triangle. And yes, let me tell you something, that if you want to be able to resolve forces, that is break them down into x and y components, you have to make sure that your concepts of trigonometry are intact. That is your basic trigonometry, sine, cos, and tan, and also sine rule and cosine rule. That is something that we will need when we are finding out the resultant. So let's come back. Imagine that you have this string over here, and let's assume that the angle that this string is forming from the horizontal is theta. So what do you have? You have a horizontal line over here, which is your base, or you can also call it the adjacent side. And then you have your vertical line over here, which is your perpendicular, which you can also call the opposite side. And what we're going to do is we're going to learn how we can resolve a force that's acting at an angle and break it down into x and y components. So let's get straight into it. All right, so here I have tried to replicate the scenario. Here we have a Batmobile, and this is the string that I was using to pull it. Now let's say that the force that I'm applying to pull it is F newtons, number one. Number two, let's also make an assumption that the angle this is forming with the horizontal is theta, okay? So basically, if you remember, we were forming, or it was a 90-degree triangle that was being formed. So that means we have the base and the perpendicular. Now I'm trying to color code it here so that it's easy for you guys to remember. So that means I should probably change this to a neutral color. So let's use blue, F and theta. Okay. Now the horizontal component we're going to refer to as Fx. F for force, X for the horizontal axis. The vertical component, we're going to refer that to as Fy. Now, how exactly can I find out Fx? Now here, because we don't have actual values, we'll do it in terms of F and theta, but let's see what the method behind is. Now, the angle that's formed is a 90-degree triangle, so obviously that's a given. So if you think about it, F is the hypotenuse, Fx is the adjacent length. Okay, so I'll write it down over here in bracket. It's the adjacent length, or it's the base if you use, some people have curly brown hair, if you use that shortcut. Just like that, Fy is the opposite length or the perpendicular. Again, if you use, some people have curly brown hair. So if I want to find out Fx, here's what I can do. I can use cos, okay, with the help of the hypotenuse, of course. So that means cos theta equals to Fx over F, which means Fx is equals to F cos theta. Just like that, if I want to find out Fy, I'll have to use sine. So sine theta is equals to opposite, which is Fy over F, which means Fy is equal to F sine theta. So there you go. That's it. That is how you resolve forces. Now, I should at this point give you a shortcut. Not a shortcut, but something that will help you remember which component is going to be what. So it's either sine or cos, okay? Now remember this one simple rule, which will save you a lot of time. The component that is always opposite the angle that you're using will be equal to hypotenuse into sine of, sorry, that's right here, hypotenuse into sine of the angle that's given, okay? Or in other words, the component that's opposite the angle will always have sine in it, and the component that's always adjacent to the angle will always have cos in it. Do not memorize it by horizontal and vertical, because later on we'll do some examples where you'll see that it's not always the horizontal component which will have cos, and just like that, it's not always the vertical component which will have cos. Okay, but the rule that I stated earlier, that is the component opposite the angle will have sine in it, and the component adjacent the angle will have cos in it, that will always hold. Okay, so let's do a few examples and see if what I've said is correct or not. Now, it says here, find the component of each force in the x direction. Now, you may be wondering what exactly is this box here for. Now, this box is, remember, whenever we're breaking it down, we need to have a sense of direction as well, okay? Now, 9 out of 10 times, in fact, always, the rightwards and the upward forces are considered positive. So that's what we're going to do. Whatever is acting rightwards or whatever is acting upwards will be considered positive, and whatever is acting leftwards or whatever is acting downwards will be considered negative. Okay, now what do I mean by that? Just hang in there, I'll explain shortly. Okay, so we're going to do all these 4 parts. So in part A, let's break it down into horizontal and vertical components. So here you go, here's the horizontal component, here's the vertical component. Now let's start with the horizontal component. Now the horizontal component is the adjacent component, okay, so we'll call it fx, and the vertical component is the opposite length, which is why we're calling it fy. Okay, so how will I find out fx? If you've understood the shortcut, I encourage you to use it. If you haven't, it's okay. I encourage you to do it step by step. So let's say we want to do it step by step. So this is what we're going to do. Since it's adjacent and we have the hypotenuse, we're going to use cos. So cos 20 equals to adjacent over hypotenuse, which is 12. So that means fx is equals to 12 cos 20. And just like that, if let's say you want to find fy, so since it's the opposite and you have the hypotenuse, that means sine 20 is equal to fy over the hypotenuse, which is 12, which means fy is equals to 12 sine 20. And there you go. That's it. That's your answer to part 1 as well as part 2. Now, part B is pretty easy. Why? Because you just have one force which is acting downwards. That means there's no horizontal component. So if you were to find out the component of this force in the x direction, that will straight away be 0. Okay. However, for part 2, because it's not acting at an angle, so we don't need to resolve it, it's just going to be minus 5 because it's acting vertically. So whenever you have a non-horizontal, non-vertical force, that is when you need to resolve it. And why minus? Because it's acting downwards. Okay, now for part C and part D, I will encourage you guys to use the shortcut. In fact, that's what I'm going to do. And I'll just switch to a neutral color now. So here's part B, here's part A. I'm sorry if you find my working a bit haphazard. And also, I should probably drag this and bring it over here. Okay, now part C. So here is the component that is opposite the angle, and here is the component that is adjacent to the angle. So the one that's opposite in the x direction will be 8 sine 40. Now notice, even though it's horizontal, but it has sine in it, okay? However, this is wrong. It's not wrong, actually, it's incomplete because it's acting leftwards, so it's going to be minus. Now for part 2, because it's adjacent to the angle, and again, although it's vertical, but it doesn't have sine in it. In fact, it's going to be 8 cos 40, okay? And there you go, that's it, that's the answer. This is how you can use the shortcut. Now, here's part D. Let's do D part 1. Again, let's make these arrows. Now, it's always a good idea to sort of mentally prepare for whether it's going to be positive or negative, okay? I mean, just make a mental note of it, okay? So if we start with the x direction, it's going to be negative, that's for sure. And x here is the adjacent side, so that means it's going to have cos. So minus 6 cos 50. And for y direction, it's right here. So because it's opposite, it's going to have sine in it, and because it's downward, it's going to be minus. So minus 6 sine 50. Now you must have noticed that I left them in terms of sine and cos. You can always turn them into decimal. That's not what the objective over here is. The objective over here is learning how to decode and basically break it down into X and Y components. Okay, when we're solving questions, I'll tell you exactly what needs to be done. But yeah, for now, this is enough. I hope you've understood this concept, and I will see you guys in the next video where we will learn how to resolve forces and find the resultant. Not just resolve forces, but resolve forces to find the resultant. And we'll be starting with category A questions or category 1 questions. So yeah, that's it. That's it for this video. I hope you've understood all the concepts. I'll see you guys in the next one. Until then, take care. Bye-bye.